Okay. It's still not screen sharing. I'm telling it to screen share and it's not screen sharing. Are you able to see? Yeah, I guess you can see the notebook, right?
Yeah, I see your OneNote for Windows.
Yeah.
Now,
yeah, that's it. Go ahead.
Sorry, my camera, I'm having issues with it. I did Zoom earlier, but I can hear you and see you fine. Is that okay?
Okay. That's fine. I don't have to see you. In fact, I'm recording the meeting and I'm going to post it. So if you don't want your face posted, then you don't have to turn your camera on. Okay. So let me go to draw. All right. So are you able to see what I draw on the screen? It looks like you do.
Yeah.
Okay, good. All right. So we're on, let me see. That's not what I wanted to do. So this is going to be interesting, but we'll do our best with it.
Okay.
I think I should be able to do it in notebook mode. That's what I was hoping for anyway. Let's see if it does what it wants, what I want it to do. Okay, let's give this a try now. So we should be on chapter 3, right?
And no, I believe the next one was chapter 17.
Okay, so I'm going to put chapter 17 at the end because it always confuses a lot of people, and it's business math. So rather than go over that right at this moment, I'm going to hold on one second.
Okay, so it's chapter 3. Yeah, that's the one that opened up when I looked up the assignment.
Yeah,
chapter 17.
I posted, or I'm posting that change because chapter 3 or chapter 17 is business math, and I want to cover it at the end because it's super easy. I had done it in the beginning. The math for it is easy. Knowing which math to use is not easy, and it does confuse a lot of people. So I want to go straight into chapter 3, if that's okay with everybody, because this is, important to know. This is numbers, time, and temperature, and then we're going to save chapter 17 for real quick at the end, because I think this is actually a little bit more important. So many of you, especially those of you who are in the nursing program, you're not actually going to have to order supplies, balance the books, and things like that. So at least I hope you don't, unless you really, really want to. Okay, if you're the manager, the office manager, you might do some of that, but still calculating gross and net profit is more in the line of real small businesses and small pharmacies and that kind of thing. So chapter 3 is all about the conversion of clinical measurements of numbers, time, and temperature. So when we look at this, we have Roman numerals, and Roman numerals are written with yeah, I'm trying to erase it with my finger. Yeah, that doesn't work. So they're written as
letters.
They're written as letters, right? Roman numerals are written as letters. So I had a Roman numeral handout that I gave you guys that I posted in module 0. So that one talks about the letters that are used for numbers, and that's because the ancient Romans didn't have different symbols for numbers, so they used letters for it. And there was no concept of 0. You either had sheep or you had no sheep, so why count them? So there was no 0. So that's one of the things we need to remember about Roman numerals. Why is it doing that? No zeros. I'm still learning this, my little pen thing. The pen thing has a little button on it, and I guess I hit the wrong button on it. Okay, so there's no zeros. 1 or capital I. 1 is written as an I or a capital I. And the way that we write it in pharmacy is to write it with a combination of upper and lowercase I. So you have the dot as if it were a lowercase I, and you have the line across as if it was part of the capital I, and that is 1. Now the numbers that we're used to seeing, 1, 2, and 3, etc., those are called Arabic numerals. And so I don't mean anything, you know, racist about that or anything. That's just what they're called. They're called Arabic numerals because they're taken from ancient Arabic writing. So they would repeat the I symbol. So you'd have 2 I's or 2 uppercase I's, or in pharmacy, okay. I don't know why it's doing that all of a sudden. Hold on a second, get back to my OneNote. We would have a double combination of those things. Or for 3, you'd have I, with the 3 dots on the top. Now, I had a doctor write a prescription for eye drops, and he wanted the patient to use 6 drops. 6 drops, so he wrote it like that, which of course is not correct. So that was really weird, and I don't know why he did that. So it made me think maybe he didn't get the Roman numerals part of his math class. Okay, so then we have a symbol for the number 5, and 5 is the upper or lowercase letter V. And we don't write it any differently than that. So when we're looking at these, we can count 3 I's and say that it's 3, 1, 2, 3 ones or 3 I's. And then for 4, it's just going to be IV, or 1 before 4. So it's written like that. And then for 6 is going to be 1 after 5. So VI is 6. And then because they can repeat these things 3 times, and it's mostly the ones, the hundreds, it's mostly the ones and the 100s and the 1000s, the big numbers or the cardinal numbers that they count more than once. So VII is going to be 7, VIII is going to be 8. And then in order to know what 9 is, you have to know what 10 is, and 10 is X. So 9 is going to be 1 before 10. Now, apparently, in the earliest Roman times, 9 would have been a V with 4 I's. But it was decided a long time ago that this was a little too hard to count, because you can easily see groups of 3, but you'd have to start counting when you start getting more than that. So then they changed it to 1 before 10. So what would 11 be?
X and I.
Yes, so that's going to be 10 and 1 after it. So it's going to be 11, because 1 after 10 is 11. And then, of course, 12. And then you see these on a clock all the time, right? And if you go to Disneyland and you ride the Haunted Mansion, you'll see 13 o'clock. And so now we're going to get to 14, and 14 is going to be 10 and 1 before 5 again. So it's XIV for 14. And then 15 would be XV, and it goes on from there. XVI is 16, and I will get better with this stylus as time goes on. So we have, that's supposed to be an X, 10, 15, 16, 17, 18. And then for 19, you're going to have 2 X's. And what you're going to do is like 10 plus 1 before 10. So 10 plus 9 is 19. And then double X is 20. Triple X actually means 30. Yeah. So it goes on like that. In order to know what 40 is, we have to know what 50 is. And from that sheet that I had you guys look at, what is 50?
L or C?
L.
L. 50 is L. So if you're 40, you're extra large,
Yes.
or 10 before 50. So you're not really extra large if you're 40, but that's how I remember that one. And then 60 would be LX, which is 50 and 10, or 10 after 50 is 60. Okay, so now let's look at a few things past that. Okay, and we have 70, which is going to be LXX. And then 50 followed by 30 is 80. And then we have 90 and we have 100, right?
Right.
So if 100 is
100.
C, and if you think about it, a century is 100 words. A centurion was an ancient Roman group of 100. They were one of 100 soldiers. So C is 100. And so 10 before 100 is going to be 90. And then 10 after 100 is going to be 110. Does that make sense?
Yes.
Okay, so that's what we're looking at there. And then we have a 500, which is a D. So CD, supposed to be a D. CD is 100 before 500, so that's going to be 400. DC would be
600.
600, good. And then M is 1,000. Okay, so M, millennia, so that's going to be 1,000. All right, fix my chair here. So then if we wanted 700, it would be 500 with 200s after it. So that's going to be 700. CM is going to be 900. And then MC is going to be 1,100. So you kind of get the idea there?
Yes.
Yeah.
Okay. So what is MM?
2000.
2,000.
2000.
Okay, so let's see what this is. This is a year. What year is that?
MCM 2000.
19.
80.
1980? No.
No, it's 190.
Yeah, 1980.
2090. LX 80.
Is that
Would it be
1980?
88.
1988?
1988.
Yes, it's 1988.
Oh, okay.
And then if you add 12 to that, then you get 2,000.
Okay.
Now, believe it or not, some math teachers will have you write math like this. Don't do that. That's just crazy. So convert it to these numbers and write it this way. Is that better?
Yes.
Okay, yeah. So we need to know how to read the Roman numerals. Now, the question then is, why in the world would they use these Roman numerals? Well, when we were talking yesterday, and we talked a little bit about the beginnings of pharmacy, before 1965 or 1967, if a person came into the pharmacy to pick up a prescription, you might find someone working there who's working the cash register. And then if they had questions for the pharmacist, they would talk to the pharmacist. The pharmacist, and they were not technicians, by the way, those other people at the counter. They were just people running the cash register, and they were considered clerks. So, and most of the time it was the pharmacist themselves that would ring them up. They were not allowed by law to tell the person picking up the prescription, even if they were the patient, what the medication was. I mean, the name was on the bottle, but they couldn't say this lowers blood pressure. This is for your high blood pressure. So they couldn't tell them what it was or what it would do to the body or what condition it was used to treat. By law in the United States, they were not allowed to do that. Doesn't that blow your mind?
Yes.
I think that's crazy. You know, personally, why would you want to do that? You know, why would you want to get into pharmacy if you can't even tell people what they're taking their medication for? So it was after, okay, so one of the reasons why they didn't do that is because doctors were very much concerned with having more control over the patient. So in other words, if a patient came in and there's a book called The Immortal Life of Henrietta Lacks, L-A-C-K-S. Have you guys heard of that book? I think they made a movie out of it with Oprah on the Oprah OWN network or whatever it was. Anyway, there was a woman named Henrietta Lacks, and she lived in the 50s in, I think it was Baltimore, Maryland. And she was really close to Johns Hopkins Medical Center. And she went there for treatment for cervical cancer. And they took a biopsy of her cells. And she had fatal cancer, but they didn't tell her that. But her cells lived on. And it was a really, if you read the book, it was just devastating what happened to her because she didn't know she was dying. So, because they thought it would give people, like it was cruel to offer them no hope. It was cruel to tell people they were dying because a miracle could happen at any moment and maybe they won't die. So that was sort of the attitude of doctors, was that they did not tell people if they were dying. So they also didn't tell people if the medication they gave them was going to cure them or just try and make them feel better. So there's something called palliative care or palliative care. So palliative means relieve suffering. Okay, so it was just to try to relieve their suffering. It was not really to cure them. So they would give them pain meds, or they would give them, like I think they did radiation treatment on Mrs. Lacks, but they didn't actually try to cure the cancer because they couldn't at that time in the 50s. So after she passed away, they had these samples, these biopsies that they had taken of her cervical tissue, and they realized that they would grow in a lab in a medium, agar medium or something like that. So they would, they were doing all kinds of research hoping to cure cancer. So the lead researcher and doctor in charge would share these cells with, as they grew, share them with other universities and colleagues to see if they, and actually started selling them, the cells. And that's, I don't know if you've heard of HeLa cells. So HeLa cells come from Henrietta Lacks, and L-A-C-K-S. And her cells are still alive today. And if you strung them all together, cell to cell to cell, they would go around the world several times. There's so many, you know, more than billions of them, because they continue to grow all the way from the 1950s. And so her children finally, in the 1990s, I believe, or in the early 2000s, Rebecca Skloot is the person that wrote the book. She was doing a research project, and she wanted to find out, where did they come from? What's the story of these cells? Because they're all over the place and you do all kinds of work in biology and medicine with them. So she did this research and she talked to the family, and the families in the beginning had no idea where the cells, you know, that they didn't know what was going on with their mother's cells. They had no idea. So it created some discord, and there was already discord in the family, but it created even more discord. And because all this time, the researchers and Johns Hopkins had actually been profiting from her cells. So they were making money from part of this woman's body, and yet her children had no health care. They had no health insurance. So, I mean, it was grossly unfair, and because of this, now there are laws that prevent people from profiting from that. And it's also one reason why, if we go like to have a gallbladder removed, we sign that they allow to test it for cancer and that sort of thing. And even sometimes it will see something like any organ or tissue removed becomes the property of whoever, whatever hospital you're at. But there's laws that prevent them from profiting from it now. So they can do research on it, but they're not allowed to profit from it now. So at least not like they did then. So it was kind of interesting. Okay, so because of that, going back to the prescription thing, because doctors didn't really want their patients to know what was going on, and also for anti-fraudulent use, when they would write a prescription for something, say pain medication, they didn't necessarily want them to know what it was. So they would write for, let's say, codeine. And they would write it like this. And so the patient looking at this, even if they knew what codeine was and they knew what 30 mg meant, they might not know what the XXX means. So of course, you know, in actuality, that is how many?
30.
30. But if they wrote it like this, the patient could take that prescription and add a 0 to it. But they might not know how to change the Roman numeral part of it, or even what it meant. So this is why they started writing Roman numerals. And then in writing the directions, they would put directions like that. So like I had in our discussion, of course, you know, we know what this means right here. And that means what?
1.
It's Roman numeral 1. So it means take 1. Oh, it's on rainbow for some reason. That's cute. Take 1 tablet. And what does the PO mean?
By mouth.
By mouth. You don't want them to put it in their ear. And what is Q for, and that degree symbol?
Every 4
hours.
Every 4 hours. And what's the PRN?
As needed.
As needed for pain. So sometimes they'll just put PRN without what it's needed for, in which case we would stop here. As needed, because the patient is assumed to know what it's needed for. Okay. Now, when we see this on a prescription, we are not allowed to add anything except the form and the route. So if this prescription had originally been written let's say that it was written this way. 1 Q4H PRN. We would still put take 1 tablet by mouth every 4 hours. If I can spell, which I can't today. As needed, but we can't add for pain because the doctor did not indicate PRN what. Okay, so maybe they're taking it to sleep. I mean, codeine does make you sleepy. So we can't assume it's for pain. So we could not put for pain, but we are supposed to put the form and the route. The form is a tablet and the route is by mouth. Is that making sense?
Yes.
Okay. Okay, good. All right. So those are Roman numerals, and practice problems A on page 63 and B on page 64 those are practice problems that have you go back and forth between Arabic numerals to Roman numbers to Arabic numerals, etc. So let's look right now at military time. And I did not scan this chapter in for you. How many of do I have people here who still don't have the book?
I don't have the book yet.
Okay, and I scanned in, did I send you guys chapter 2?
I sent 1 and 2.
I sent you 1 and 2, okay. I have to send you chapter 3. Because I still have people who don't have the book, and it's still only barely the second week, so I think I can do that. And the homework is posted, okay. So let's look at military time. Do I have any service members or former service members in class? Anybody been in the military? No? Okay. So if you're in the military, then the time thing is no problem because, you know, you're used to military time. What I had to do when I started teaching this, what page was I on? Okay, page 65. What I did was I set my phone where it shows the time, I set it to military time on the front of my phone. And then it would get me used to it because I would have to go, what's 15:30? And I'd have to subtract 12 from it to get 3:30. So I got used to that. So there's a little thing here on page 65 that looks like a clock. And I have to do the 4 directions first so then I can fill in the parts here. Okay, so this is the AM is going to look like this, and there's going to be a 0 in front of any single digit. So this is going to be 01, 02, 03, 04, 05, 06, 07, 08, 09, and then 10, 11, 12. The inside is the AM, and the outside is the PM. And then we add 12 to all of these. So 1 goes to 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then depending on if it's international time or military time, 12 is going to be 00, but in some countries, midnight is 2400, and then it goes to 01 after that. So most of the time that we're going to go with 00, and so if we're looking at this, 0043 is going to be 12:43 a.m. Okay, because there's no hours, so it has to be in the first hour between midnight and 1 a.m. and it's 43 minutes after that hour. So we don't have a colon here. We don't put the 2 dots there. So we're not going to put the ... We don't use that. And it also does not say AM or PM. And that's because if we were writing very quickly and we were writing, we wouldn't know if that's AM or PM, right? It's a squiggle. So besides the fact that, you know, doctors have always had this reputation from years ago of having notoriously poor handwriting, also, you know, it just is easier to read this way. So that's, you know, the military time thing. And if you go So basically, if it's after 12 noon, you're going to add 12 to the hours. So 3 p.m. would be 1500. And 6 p.m. is 1800. So we call the 00s 100. 1847 would be 6:47 p.m. Okay. And when you get to 2200, 22:15, what time is that going to be?
That's 10,
10.
Yeah, 10:15 a.m.
No.
It's going to be p.m. because it's afternoon. So when you add 12 to all of these, any number bigger than 12 is going to be p.m. Any number 12 or smaller is going to be a.m. Okay, because 12 is always noon. And then 0000 is going to be midnight. So the clock resets at midnight and it goes back to 0. And then you start all over again with 0001, which is going to be 12:01 a.m. Okay, so it's 1 minute after midnight.
Mhm.
Okay, so those are the Roman numerals. And once you get used to doing that, and you know, if you want to set your phone to military time, I think it's really helpful because, you know, you'll be out somewhere in the middle of the morning and you'll be going, you know, in the middle of the morning, the time is correct. But in the afternoon is when you're going to have to start adding 12 to things. And if you are translating back from, say, 1412, and you subtract 12 from that, that will tell you that it's 2:12 p.m. Okay, so 1412 would be 2:12 p.m. Okay, any questions on military time? And the other time is called standard time or traditional time.
Mhm.
Professor?
Okay, so page 64 gives you the conversion at the bottom of the page between 12-hour and universal or military or 24-hour time. Okay. All right, the next thing that we can look at on page 66 is the conversion between Fahrenheit and Celsius temperature. Another temperature that's used a lot, especially in like astrophysics, is the Kelvin temperature scale. And we're not going to use the Kelvin temperature scale, so you don't have to worry about that one. What do we use here in the US? Do we use Fahrenheit or Celsius?
Fahrenheit.
We use Fahrenheit. So if it's 85 degrees, is that going to be warm or cold outside?
Warm.
Warm.
Warm. Is it really hot?
Not too much.
No.
Yes.
It's not.
Depends, right?
I'm okay with 85 unless I'm indoors, then I want it a little bit cooler. But if I'm at the beach, oh, I love 85 because you have that sea breeze coming with it and it feels even cooler, right? So 85 degrees Fahrenheit. Let's see if we can convert that to Celsius. And if you look on page 67, I don't use the 5/9, 5/9, or 9/5 because that's a fraction. And in my brain, all fractions get converted to decimals anyway. And if I can't do it in my brain, I grab a calculator. So if I'm going to convert from Fahrenheit to Celsius, the first thing I'm going to do is I'm going to take the Fahrenheit and I'm going to subtract 32, and then I'm going to divide by 1.8. Okay, so Celsius equals the Fahrenheit minus 32, and you're going to do that one first, so you need parentheses around it. Otherwise, you would normally divide first, right? So we don't want to do that. So 85 minus 32 on my handy dandy Texas Instruments calculator is 53. And then I'm going to divide by 1.8. 53 divided by 1.8. And I get 29.4 repeating, right? Okay, so for temperatures, you can go to 2 decimal places. We don't normally go to any decimal places. But tell you what, let's go ahead and go to 1 decimal place on temperatures, okay? So let's do 1 decimal place on temperatures. Okay, so let's look at something else. Let's say that I have a friend in Canada, which I do, and she says, oh, it was really warm. It was 31 degrees Celsius. It was 31 degrees here. And I'm thinking 31, that's below freezing. Oh my God. And then I remember, oh no, never mind, it's Celsius. So how much would that be? How much would 31 Celsius be in Fahrenheit? So let's look at this. And on page 67, it tells you to take that Celsius times 1.8 and then add 32. And when we get the Celsius is 31 times 1.8, which gives us 55.8, and then we add 32.
That'll be 87.8.
Yeah, 87.8.
87.8 Fahrenheit. So if you're a Canadian and you're living, you know, so far north of us, I just can't handle the, I've been there once to visit her. She's real close to Toronto. So she's close to the Great Lakes, and she's actually higher than like Minnesota, and Minnesota to me was freezing. So 87.8 feels really warm to them. They will be out there in the snow barbecuing because she grew up in Orange County. So she grew up in Anaheim, Santa Ana, and all of that. And so when they moved there, she said it felt really cold to her for the first winter. And after that, she got used to it. And her husband also grew up here. And he said, well, if you don't barbecue in the snow, when are you going to get to barbecue? So I was like, they have barbecues out on their back porch. Yeah, you dust off the snow, you throw your charcoal in, and you start barbecuing. Okay. You know, we kind of think of that as a spring, summer, fall activity, but that's okay. All right. So what for you guys is going to be really important later is knowing what is a normal body temperature, right? So what is a normal body temperature? The perfect body temperature we always want to see if we take someone's temperature.
98.6.
97.5 or something.
98.6.
98.6 Fahrenheit. Okay, so what does that equal in Celsius?
37, I think.
What is it?
37.
37? Probably. That sounds about right. Let's see. So there's the Fahrenheit. Let's convert it to Celsius. So we're going to take 98.6 minus 32. And I get 66.6, and I'm going to divide that by 1.8.
37. Yep, she's right. 37.
Very good.
Yeah.
So what if your patient shows up and you just happen to be working in Toronto and they show up with a temperature of 40? How high is that? 40 degrees Celsius. Is that the area where they're going to go into seizures or not?
Yeah.
It is?
Yeah.
Okay. I think you've worked with Celsius before.
Yes.
Raja.
All my life.
Well, you can log off now if you want. No, I'm kidding. Please don't. Okay, so what is 40? Let's see. 40 times 1.8 72 plus 32, what does that equal?
104.
104 degrees Fahrenheit. Now, if this is a, oh, I don't know, a 1-year-old, they might be okay, but you're probably going to start giving them some Tylenol or Advil, aren't you? Because this is kind of high. For adults, you don't want it to go over what, maybe 101?
Yes.
If I hit 100, I'm like, honey, I need some Tylenol. Honey, I need some Advil. This is, I'm so hot. And then of course I get sweats and I get clammy and then I get chills and it was, well, I'm sorry, that was swine flu. Never mind. Okay, so if they show up and they come in and their internal temperature is, let's see, okay, let's say that they're at 34 degrees Celsius. We just pulled them out of the freezing cold, I don't know, one of the Great Lakes, whichever one is close to Toronto. I think it's Lake Erie. What do you get for that body temperature of 34 degrees Celsius?
Mm-hmm.
93.2.
93.2.
That's what I got. So what did we do? We took the 34 times 1.8 and we get 61.2 plus 32 and we get 93.2. Okay, so 93.2. So good job, you guys. So what page was I on? Okay, so page 69 gives you a whole bunch of problems to convert back and forth. On 69, I like number 18. It says a parenteral medication arrives through the mail. The label on the box states that the medication cannot be exposed to temperatures higher than 47.8 Celsius. So it has to be no greater than, so it should be, let's see, less than or equal to 47.8 Celsius. The current outdoor temperature is 100.2 degrees Fahrenheit. And this happens a lot because in the US, a lot of our drugs are manufactured in other countries. And why we're still hanging on to the Fahrenheit scale, I'm not sure, because so many more countries use Celsius. You know, pretty much all of Eastern and Western Europe use Celsius. So we get these medications and they'll give us the Celsius temps as in store it below this. So does that mean, what is the temperature in Fahrenheit? What is, okay, so what is our current temperature in Fahrenheit in Celsius, and can the medication be safely used? So we'll convert the 100.2. So again, we're gonna take the 100.2, and the first thing we do is
Subtract 32 from 100.2.
subtract 32, and we get 68.2. And then we divide it by
1.8.
1.8.
Give you 37.9 degrees Celsius.
Why did I get 37.88?
Oh, didn't you still get to?
Yeah, I got 37.9. I just rounded up.
I just rounded up by one.
Oh, I see. Okay, so 37.9. Good. So can the medication be safely used?
Yes.
Yes.
Okay, good. So that's number 18 on page 69. Okay. And then your post-test is on page 70 through 72. I like this. It says an order shows on page 72, number 44. An order shows to dispense XC tablets. How many tablets is that?
90.
Okay, good. All right, so that's chapter 3, and we really get into real pharmacy. I mean, this is still real pharmacy because we use all of this in pharmacy. But when we get to chapter 6 is when we get into conversions that we're actually going to use. Okay, so we want to get all the basics down first, and this was one thing that I did talk to Elaine Beal, she was your author. I didn't speak with her, but we've emailed back and forth a few times. And I said, it seems like the first 5 chapters are things that people should already know, especially at the college level. And what she said is that she still gets a whole lot of people who have problems with universal time versus military time, and even things like basic math skills, if they are, like, nobody really likes to do fractions, it seems like. You know, a lot of people don't like to do fractions. So she actually would spend more time on the first 3 chapters with her students. What was chapter 4 again? Okay, measurement systems, units, and equivalencies. So that's going to get into a lot of pharmacy too, because you have to know what the different units are. Okay, so one thing I want to talk about is the whole issue of decimal points, okay? I don't like to use fractions if we can use decimals, because decimals are more, well, actually fractions are more exact, but a lot of people can't look at it and really understand what it means with a decimal, so, or with a fraction. So with a decimal, a lot of it depends on how many decimal places you go to. So let's say that we want to dispense number, or let's say that we want to dispense for a patient 1/2 milligram. So let's say that it is a drug, what comes in 1/2 milligram? Now I'm thinking micrograms. Okay, so let's say alprazolam. Alprazolam. What is that brand name? Anybody know off the top of your head? Oh, isn't it Xanax? I know it's a benzodiazepine. I think it's Xanax. Let me just look it up real quick in my handy dandy drug reference for health professionals. When you deal with generic drugs all the time, you tend to forget the brand names. Yeah, Xanax. Okay. Xanax. So let's say that we want to give 1/2 milligram. So if we look on our bottle, it doesn't say 1/2 milligram, it says 0.5 milligrams. So can we write it that way, or can we write 0.5 milligrams?
We need to put the 0, then the decimal, then 5.
We need the 0?
Yes.
I can be mistaken for 5 milligrams.
Exactly, because if somebody doesn't see that decimal point, they might think that it's 5 milligrams, and how much of an error would that be?
Very big error.
Very big, yeah. It's
Gonna
like
knock somebody out.
20 times more.
Might even kill them. That's a 10 times error. So it's
Right.
like you gave them 10 tablets instead of 1, right? Okay, so that would be very, very bad. So we want a leading 0. I can't even, look, I'm gonna write Zorro instead of 0. A leading 0 if it's less than 1.
Yeah.
Okay, so if it's 0.5 or 0.25, but let's say that we wanted to give someone 5 milligrams of something like lisinopril. So, you know, that comes in 5, 10, 20, and 40. So if we wanted to give them 5 milligrams, can we write 5.0 milligrams?
No, no,
That
Why not?
could be
because some people,
50.
sorry, some people don't. Okay,
Maribel,
go Maribel, go.
You're saying it could be mistaken for 50.
if they don't see that decimal point, right?
Yeah.
Exactly. Okay. So we don't want to write 5.0. Those are called trailing zeros. Or whole numbers. Okay, so don't use trailing zeros for whole numbers, but you do use leading zeros if it's less than 1.
Yeah.
Okay? All right. Is that making sense?
Yes.
Leading zeros are good, trailing zeros are not.
Yeah.
Okay. We don't want them to trail along, but they can lead. All right. Let me go back to chapter 2 a little bit, just to make sure that we have a couple of things going on here. Can you solve that one for x?
No, 77.
Okay, how did you get that?
Because 3 times 11, 33, 7 times 11, 77.
Okay, so you're saying that x equals 77.
Yes.
Okay, so there's a couple different ways you can do that. And if, like Saja, you can just do that in your head. She's looking at the first numbers. How do you get from 3 to 33? You multiply by 11. So then you take the next numbers and you do the same thing, times 11, and you get 77.
And
So if you're going to multiply the ones that you know, like how do you get from one to the other, and then the other numbers you're going to do the same thing too.
and
Okay.
we can use arrows, like 3 over 7 equal 33 over x.
Okay, and then what do? You cross multiply, right?
Yes.
And then divide both sides by 3.
By 3, and this one by 3 too.
And you get 77, yes?
Yes.
Okay, so if you can look at this and you can go, oh, this is just 11 times more, and then you can do this, oh, that has to be 11 times more too, and you can do it in your head, then that's fine. There's never just one way to solve most math problems, okay? Most math problems, there's more than one way to solve them. Okay, does that make sense?
Yes.
Yes.
Okay. All right. So let's do one more thing involved with basic math. Let's look at, wait a minute. Okay, so let's take a fraction like 1/2. how would we express that as a decimal?
0.5 or 10 divided by 2.
0.5, which is on your calculator, 1 divided by 2. So it's top divided by bottom to go from fraction to decimal. Now, how do we go from decimal to percent?
We multiply it by 100.
Times 100. So 0.5 times 100 is
50.
50.
50%, right? Because isn't a half 50% of the whole? And what would that be as a ratio?
1 to 2.
1 to 2 or 50 to 100.
So you could do 1 to 2, or if it's 50%, that's going to be 50
to 100.
to 100. Now, both of these are correct. Which one is more correct? The 1 to 2 or the 50 to 100?
I think 1 to 2.
2.
Yeah, it's going to be 1 to 2 because that's the simplest terms. But also, when we're looking at these things in, as far as pharmacy goes, what we're looking at here is 1 gram in 2 milliliters. So it's always, the ratio is going to be grams to milliliters, and the fraction is going to be grams over milliliters. So when we get a little farther in this book, that's what we're going to look at. And something like if you have a 1 to 1,000 ratio, it's going to be 1 gram in 1,000 milliliters. And that's also going to be 1,000 milligrams in 1,000 milliliters, which is going to be 1 gram per milliliter. Okay, so a 1 to 1,000 ratio is 1 gram per milliliter. Okay, so that's a preview of coming attractions here. So we aren't getting into that just yet, but we will get into that shortly. Okay, so the fraction, decimal ratio, percent and ratio, we have to be able to go back and forth between all of those things with whatever number we get. So let's try one more. Let's do fraction, decimal, percent, and ratio. And let's take a decimal of 0.37. And that one's going to be fun because it's an odd number.
So
What's the easiest one to convert to first?
percent,
Percent is going to be what?
37%.
37%, because you take this and you multiply by 100, right? So what is that as a ratio?
37 to 100.
So that's going to be 37 to 100. Can we simplify that?
No.
No.
No, I'm hearing a couple of no's. Why not?
We can do like 3.7 to 10.
Well, then we'd have a decimal in a ratio.
We can't, right?
So we're not going to do that. We always want whole numbers with a ratio.
Okay.
So the short answer there is no. I mean, you can, but that's not the math that we're doing.
Okay.
What is that as a fraction?
37 over 100.
Yep, 37 over 100. Okay, how about $12.5%? That looks weird, doesn't it? This is what, you might see this on, well, I don't know, years ago they would tell us that that was our interest rate on cars. My very first car had an interest rate of 22 point something percent. It was bad. It was 22%. Yeah, it was ouch, definitely. And it was 1981. And so I refinanced it within a year at about 12%, which was so much better. So instead of 12.5, we'll call it 12.5%. And you sometimes see that fractions and then percents. So what is that as a decimal?
0.125.
Yeah, so I'm going back the other way, right? So I'm going to divide by 100 and I get 0.125. So what am I missing here?
No, it's 12.5. No, no, sorry, you're right. A 0?
Yes. I like this pad. I'm going to keep it.
Oh,
Because I already paid for it. So yeah, what do I need here? A leading 0, right? 0.125. Okay, so what have we got as far as a ratio?
125 to 1,000.
No.
Okay, so you're saying 125 to 1,000.
Yes.
Why is it not 12.5 to 100?
Because we need a whole number.
Yeah, didn't we just say we didn't want to put a decimal on this one? So we don't want to put a decimal on this one either.
And we can make it like 5.
Could be
5.
1 to 8 if you simplify it.
We can do it, I think, 5 to 100 also.
Yeah, look
No.
at this. We've got both of these numbers are numbers that are divisible by 25, isn't it?
Yes.
right.
Yeah.
So 125 divided by 5 or divided by 25 is 5.
5.
And what's the 1,000 divided by 25?
40.
40.
Or
Can we still simplify?
Yes, 1 to 8.
Okay, so if we take the 5 and divide it by 5, we get 1.
1
And
and
if we take
8.
the 40 divided by 5, we get
1 to 8.
8. So what's our fraction now?
1 over 8.
1 over 8.
Yep, 1 over 8. Very good. Okay. Let's go ahead and do one more because these are so much fun. Let's say that we are going to give an effort, one of our efforts. We're going to give it 110%. We're going to give 110%.
It's
Is that really possible?
no.
Well, it kind of depends. Like if you promise someone $100 and you give them $110, that's possible. But if you promise them a whole puppy, can you give them a puppy and 10% of a puppy?
No.
No.
I hope not. That would be disgusting. Okay, so 100% and 10% sometimes does not exist, but sometimes it does. So what is that as, let's say, what is that as a decimal?
1.1.
I'll let you go through this on your own and then we'll wait a minute and then we'll get our answers here.
Okay.
Okay.
I am done.
Okay. We'll give it another minute here.
Okay.
1,000.
Ruben, what kind of dog do you have?
I'm sorry?
What kind of dog do you have?
Oh, it's a German Shepherd mixed with Akita.
Ooh, I heard that deep bark.
Yes.
I had an Aussie with that, oof, that deep bark. And when he was playing, he would do a puppy bark. Arf, arf. It was the funniest thing to hear coming out of his mouth.
No, he's a pretty good dog. Very, very calm and yeah,
He heard something.
good protector.
That's nice. That's nice. We should have a dog day and show off our dogs one day, or cats.
I have a little one too.
You do? What kind?
Mixed Chihuahua with Yorkie.
Oh, how cute. I bet that's cute.
I have 3 of them.
You do?
Yorkie.
Yeah, I have a teacup Yorkie, a little Frenchie, and a Doberman Pinscher.
Oh, wow. Yeah, we're going to have a pet day.
Right.
Maybe toward the end of the semester. That would be fun. You guys have already seen my little one. He's a Cocker Spaniel mix. And then I also have a Sheltie mix that's a little bit bigger. He doesn't think he fits in my lap, but if I'm on the couch, he'll be in my lap. And I'll be like, you fit on the couch. Why do you not fit on the chair? Okay, so let's see. Saja already has the answer here. What did you get for the fraction?
For the fraction 11 over 10.
11 over 10,
And
which
for-
is, if we simplify that, what is it if we simplify it?
It's 1 and 1 over 10.
Yep, 1 and 1/10. And what did you get for the decimal?
1.1.
1.1, very good. And what about the ratio?
11 to 10.
11 to 10. Okay, very good.
Thank you.
So are you guys feeling comfortable with this now?
Yes.
Yeah.
Okay, so how about the Roman numerals?
Yeah, I've been studying your chart you gave us. I printed it out.
Yeah, me too.
Okay, did that help?
Yes.
Good, because I totally did that off the top of my head, so I was hoping it would be helpful. You know how sometimes you have a picture in your head and nobody else looks at it the same way, so when you try to explain it, they don't get it? That sometimes happens. But I've had good success with that one. I've used it about 10 years now. Okay, what about the military time thing?
I need to study it. I'm not studying it, so
Yeah. In the book, in chapter 3, there is, if you have it, there is a sample there. Let me find out what page it is. Pretty good sample of the clock.
yeah, I think page 66.
Yeah.
Yeah,
It's page 65, chapter 3.
65, yeah.
Good.
And-
So page 65 shows the clock, and it does a much better job of drawing that clock than I did, because I don't teach art on the weekends. I used to stand in front of the whiteboard and draw something like that, and then I would turn around and say, I teach art on the weekends. Because obviously I do not. I might if I had, a circle to actually trace, but I don't, so. Okay. So look at that, and the setting your phone to military time really does seem to help. And hopefully you won't have to set it back to standard time because you don't know what time it is. You can't figure it out. But if it's afternoon, you're going to take your military time and subtract 12. So if it says 1500, what time is that?
3 o'clock.
3 p.m., right?
Yeah.
What if it says 0300?
Or 300.
3 a.m.
That's going to be
3
3 a.m. So once you get used to looking at it that way, then it is easier, than just doing it on paper. Okay, so try that if you are able to, or if you would like to. If you don't need to, no big deal. Fahrenheit and Celsius. Now, on page 67, it gives you a different formula than the one that I normally use. I don't like that formula because of the fraction thing, because you're going to have to take the Fahrenheit, multiply by 9, divide by 5, and then add 32. I would much rather multiply by 1.8 because, you know, I usually have the calculator on my phone if I don't have my little Texas Instruments calculator. So how are you going to multiply by 9 over 5 on your phone? You're going to have to multiply by 9, divide by 5, right? And how do you remember if it's 9 over 5 or 5 over 9? So if you're going from Celsius to Fahrenheit, it's from Celsius to Fahrenheit, it's 9 over 5. From Fahrenheit to Celsius, it's 5 over 9. That's hard for me to remember. The 1.8 is easier to remember. And the other thing I remember too is that the freezing point of water, and this is on page 67 of your book, the freezing point of water in Fahrenheit is 32 degrees. And Celsius is 0, which actually makes more sense. I don't know why Dr. Fahrenheit or whoever he was that did this, haven't read up on him yet. I did read up, but I don't remember. It must not have been that interesting to me. He set the freezing point of water at 32 degrees. So if we're looking at something that's below 0, that's way below freezing, isn't it? But in Celsius, below 0 is just below freezing. So one more thing that we need to know that is not necessary. Oh, and also every single degree of Fahrenheit is, in Celsius, is 1.8 times larger. So going from 1 degree in Fahrenheit, you would be looking at
1.8.
and then 2 is going to be way up there, okay?
Yeah.
So the Celsius have larger degrees, okay? So there's fewer of them between freezing and boiling. So instead of 212, it's 100, okay? So that's how I remember if I'm going from Celsius to Fahrenheit, I'm going to times 1.8 because I have to have more of them.
Yes.
And I'm going to have to add 32 to get to Fahrenheit. So then going the other way from,
Fahrenheit to Celsius.
yeah. I'm going to have to subtract the 32 first and then divide by 1.8 because you have to subtract that 32 first because you don't need it in the difference between you know, the actual degrees. You don't want that 32 stuck in there. So you do the math first and then in Fahrenheit, you do the math first and then you change it 32 degrees. In Celsius, you bring it down 32 degrees first and then do the conversion math. Okay? All right, let's look at temperatures as far as drug storage goes because this becomes very important later. We have freezing. We have fridge or refrigerator. We have cool. We have room temp. And we have warm. Okay. There are a few drugs that have to be kept warm. Does anybody know one off the top of your head? No? One of them is called mannitol.
For what? Menthol?
Mannitol is a diuretic, and it lowers blood pressure because it's a diuretic. And if it gets cold, if it gets below about 80 degrees, it starts to crystallize. So we have to keep it in a warmer. So we get it without a lot of temperature control. We get it at room temperature, and we can see some crystals in it. And we put it in the warmer. So it's similar to a blanket warmer, and it keeps it somewhere between 90 and 90, I don't remember the exact range, but it should not be more than about 104, because by the time you add it to a drug preparation and take it to the patient, it should not still be above about 100. So our mannitol warmer is almost always about 98 degrees, 99 degrees. We keep it around body temperature. So freezing is going to be below 2 degrees Celsius. And in Fahrenheit, that's, let's see, the refrigerator is 2 to 8. Cool is 8 to, okay, so yeah, I'm getting them confused here. I think I need to take out room temp. Okay, so it's 8 to 15. And then 15 to 30. Okay, so that's where we are. So room temperature needs to be really close to cool, actually. Okay, so that's room temp. So if we convert these to Fahrenheit, below 2 is going to be below 36 degrees Fahrenheit. So 2 times 1.8 equals plus 32 is 35.6, which we round to 36 degrees. We round it down, or we round it up. So 2 to 8 is going to be 36 to 46 degrees Fahrenheit. 8 to 15 is going to be 46 to whatever 15 is. 15 times 1.8 equals plus 32 equals 59 degrees. And then warm is going to be 59 to, I think 30 is 86. Okay, so that's the temperature range for drug storage.
So are you putting cool and room temp in the same?
Yes,
Okay.
I'm putting cool and room temperature because you know what? You are correct. I did this wrong. Okay. That's room temp is 15 to 30, even though technically it should actually be 72 degrees, which is the average room temp. And then cool, or sorry, I think I need to go take a nap. Warm. Warm is going to be above 30, which is above 86 degrees Fahrenheit. Okay, so there we go. So the mannitol goes in a warmer that's actually kept a lot warmer than 86. Most drug storage, if you look at the bottle, it will say keep it at a controlled temperature or controlled room temperature, and it's going to be similar to 59 to 86. So 72 degrees is average. Okay. Okay. So when I had chemistry at Riverside Community College 100 years ago, not quite, but almost. And when I would walk in the lab, we would have to get out the thermometer and we would have to document the temperature in the room. And that temperature was always 22 degrees Celsius. And if you hit the little switch on the back that went between Fahrenheit and Celsius, that became my point of reference in my head. So my point of reference was that 22 Celsius is equal to 72 Fahrenheit. And of course, it's not exact. It's, you know, if you use some creative rounding. But if my friend tells me that it's 25 degrees in my head in Canada, in my head, I go, well, that's more than 72. If she tells me that it's 15 degrees, then I'm going to go, 72 is 22. 15 is a lot colder. That's pretty cold. So that's the point of reference in my head. And when I'm doing this sort of math, if I get a number that doesn't make any sense to me, you know, I can go back to this reference point. 72 degrees is the average room temperature. And that's 22 Celsius in, you know, in Canada. So that's where I get that frame of reference. And that gives you sort of a baseline to compare. Okay, does that make sense?
Yes.
Okay, so it's actually 71.6, but you know, like I said, we're creatively rounding here, and that's where we get that. Okay. If we look at negative numbers in Celsius, it becomes a little bit more difficult because of the 32 thing. People start to get confused a little bit. So let's say that it's -9 degrees Celsius. How much would that be in Fahrenheit?
$15.8.
Yes, 15.8.
Okay, how did you start with that?
I multiplied -9 by 1.8 in multiplication. It takes the negative on, and then I just subtracted not whatever, what, 16.2 from 32.
Yes.
Okay, I see what you're saying. So you have the negative 16.2 and you add 32 and you get 15.8. Good. So do you need that positive negative key on your calculator?
Yes.
Yeah, it helped me to
Yeah.
start. So you might, okay, let's see,
What is it?
-9 times 1.8. Yeah, so it works on my phone too. Sometimes different calculators will do different things with the square root key. Is that the one I'm thinking of? Oh, it's the percent key that sometimes messes up or does different things on different calculators. So we can talk about that a little bit later as we get to that type of problem. I don't think we're going to have an issue with that in the next few chapters, though. Okay, any questions on chapter 3?
No, but please, can I know what is the homework for chapter 3? It's also the post-test?
It's a post-test, yeah. Just the post-test.
So are we doing chapter 3 this week instead of chapter 17?
Yes, we're going to move chapter 17 to the end, and I need to put that in announcements. I'm making notes to myself as I go.
So chapter 3 submissions open right now?
Chapter 3, the homework homework assignment should be open, yes.
Okay.
Are
Thank
you gonna adjust the due date to September 3rd instead, or keep it at September 10th?
I'm not real concerned about that. And I do need to change the due date on chapter 17. In fact, I'm going to unpublish it.
Okay.
And I'll change that due date later. My main thing is, because we have 17 weeks and the 17th week is the finals week. When we get to chapter 14, 15, and 16, sometimes we need more time on those because we're looking at allegations, which is something like, well, if you look at page 373, a physician orders 80 milliliters of a 1 to 1,000 stock solution. In stock is a 1 to 250 solution. So you have to, and then they want to know how many milliliters of stock solution, and how many milliliters of solvent are needed. Or if you're combining 2% and you want to get a third percent, like on page 383, prepare 2.5 grams of hydrocortisone ointment, 7.6%. The available strengths are 2.5% and 10%. So how many grams of each need to be combined to fill the order? So then we're going to be doing allegations. So, and then in Chapter 16, which is drop factors, 150 milliliters with a drop factor of 60 drops per minute and an infusion rate of 0.5 milliliter per minute. How long in hours will it take the fluid to be infused? So we get into a lot of word problems, and they look really wordy and they look really confusing, but I like to spend time on them because there are ways to do them that make sense, okay? So Chapter 17 to me is the least important chapter of the book. I used to think, let's get it out of the way, but the problem is that we tend to trip over a little bump, and then that delays everything else. So if we don't get to that chapter by the end of the semester, I'm not going to be heartbroken. And I don't think you're going to get, I don't think my nurses are going to have anything like business math on the HESI. Let's put it that way. And I have a lot of nursing majors. My pharmacy techs might have one problem in all of the 90 problems, and it's probably going to be on overhead. So we can cover that very quickly in the last week, and I don't think that's going to be a problem. So I've decided to not do it right after chapter 1 or 2. Okay?
Okay.
Okay, because I really want to spend more time on the more complex problems toward the end of the semester. And I think that's why it's chapter 17, because I really think Elaine Beale felt the same way about that chapter. But it keeps coming up in all of the pharmacy math books, so, you know, we do it. Okay, does anybody have any questions on chapter 3?
So you'll be scanning chapter 3 for the people who don't have the textbook, right?
I'm going to scan it in, yes. In fact, I have to do that as soon as I close the meeting. I'm going to do that because I also have to do the other book for their chapter 3 as well. Okay.
Okay. Thank
Any
you.
other questions?
No, thank you.
No,
Okay.
thank you. Mhm.
Were you
No.
able to see the Zoom meeting on the YouTube channel?
Yes, I ran through the one you recorded.
Yes.
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 Okay, good. All right. So I just wanted to make sure you guys could see that.
This one will also be on YouTube, correct?
Yes.
Okay.
Yeah, I'm going to post it also. The only thing is I can't make it unlisted because then it's not showing up for some reason. So not even for me. Like I thought if it was private, it would only show up for me and a couple people that I send the link to. And unlisted, I thought you had to have the link to look at it, but when I unlisted it, it didn't show up at all. But it is private. I will tell you that my channel gets almost no hits because I don't tag anything, so it doesn't come up on a lot of searches. So if you don't have the link, to the actual video, you'd have to look for Kim Lopez Instructor to find it. And then it'll come up, Kim Lopez Instructor, okay? And then you should be able to come up on a search that way. Otherwise, there are a whole lot of Kim Lopez videos out there, and I don't know if I recommend you watch all of them. I haven't looked at them. Maybe they're inappropriate, but they're not me, okay? If they're inappropriate, they're not me. Just so you know, I'm not a 20-something with a very taut body. Be nice, but no, those days are gone. Okay, anybody else have any questions?
No, thank you.
No.
Okay, all right. Thank you so much and have a nice afternoon.
Same to you.
Thank you.
Thank you.
See you
Bye.
Email me through Canvas if you have any questions.
Thank
Okay,
you.
thank you.
Thank you.
Bye.
Bye.